Next, a conceptual question comes very often, that is, while catching a ball, a cricketer withdraws his hand. Withdraws means, you have seen, when they catches the ball, they does this like this, means pull his hand little bit backward. So see here, withdraws his hand along with the ball. There is a very strong scientific reason behind this, and we will explain that with the help of Newton's second law of motion. So my answer, this is a 3-mark question, remember. So my answer is from second, this is the answer. So from second law of motion, we all know force equals to change in momentum by time, rate of change of momentum. So I am writing the just previous step, that is change in momentum divided by time. So that gives me the rate of change of momentum. Now see, I am assuming the ball initially moving, have mass m, initially moving with velocity u. When the fielder stops the ball, that means the final velocity of the ball when the ball stops, then I can say final velocity of the ball, that is v equals 0. So what about this one? So change in momentum, that is force applied on the hand. So I can write final momentum minus initial momentum. So divided by time. So what is the final momentum? Force equals, we all know, mv, that is final momentum, v is the final velocity, minus mu divided by t. So the velocity is equals to 0. So that becomes, this part is 0, equals to minus mu by t. Remember, this minus sign have a special significance. That is, here the force is acting opposite to the direction of motion. See here, when the ball hits the hand, the fielder applies a same and equal force opposite to the direction of the ball. That opposite direction signifies the minus sign, but force cannot be negative. I am taking that mu divided by t. So this is my expression for force when the ball stops in his hand. Now here they have mentioned there are two types of stopping: when the fielder is not taking his hand backward and when the fielder is taking his hand backward. First of all, think about this one. When the fielder is not withdrawing his hand, means the hand is like this. What will be the time for the stopping the ball? Very small. But when the fielder does like this, when he pulls the hand little bit backward, this time required to stop the ball will be less. And time is less. If the denominator of the fraction is less, the force will be high. If the denominator of the fraction is more, then the force will be less. So I can write when fielder do not withdraw his hand. In that case, I am taking the force acting on the hand of the fielder is mu by t1. And when he withdraws his hand, when the fielder withdraws his hand, then I am taking the force acting on the hand of the fielder is F2, that will be mu by only the thing change, that is T2. Now, when he withdraws his hand, that is pull his hand backward, then T2 will be greater than T1. So I can write and try to write the answer like this in a numerical form: T2 greater than T1, because here he is stopping the ball without withdrawing the hand, means suddenly stop. T is very small. Here he is pulling his hand backward, that is T2 is greater. So when T2 is greater, force applied on the hand, that is fraction, will be less. So I can write that is force acting on this one. Why? Because the denominator is less, the fraction will be high. F1 is greater than F2. So when he withdraws his hand, the force acting on the hand means the force with which the ball hits the hand will be less when he withdraws his hand. But when he stops like this, he will feel a great deal of pain on his hand because the force applied by the ball on the hand of the fielder will be much more high. Those who play cricket, you know this, that it's hard. When you stops a very fast moving ball, suddenly it hurts very much in your palm. So that is the reason who withdrawing the hand when he catches the ball. The similar example, it is given in your book. An athlete often lands on a sand after taking a high jump. The same reason, time of impact. We will learn this thing more elaborately in higher classes. So remember, this is called time of impact. Remember this T. To be more precise, those who are interested in physics, so learn this term. This is called time of impact. So remember this thing, and I have told you once, that is called impulsive force or impulse of a force. We will be gradually getting into that. So time of impact means the time with which the ball is in contact, coming contact with the hand. And when the glass vessel falls on the hard floor, they break, but they do not break when they fall on a carpet. When the glass bottle falls on a carpet, and it will be a sponge-like thing. So the impact, the force acting by the ground on the glass will be less than directly falling onto the floor. So I'll explain your answer like this in a numerical form. So I'm telling you, when the ball is stopping, that means final velocity is 0, initial velocity is u, and the mass of the ball is m. We know from the second law of motion, force equals to changing momentum by time, that is rate of change of momentum. Changing momentum means final momentum minus initial momentum by time. Final velocity is 0, that's why final momentum is 0 minus mu by t. So force cannot be negative. What is the significance of the negative sign? That is, here the force acting opposite to the direction of motion. That gives me the expression for force in this case equal to mu by t. T is time of impact. When the fielder withdraws the ball, when the athlete jumps on a floor, on a foam, or when a glass beaker falls on a carpet, and this type of falling needs more time. So in this expression, try to explain when that object falls on a soft surface, the time of impact will be greater. So the reaction force, this force is known as reaction force. After this, we will be learning that Newton's third law of motion. So the force acting on that object will be less, hence less pain is required of fate. Glass beaker does not break. This is the explanation for those questions. Now we'll start one numericals related to second law of motion, and you can expect one numerical from here. See, I have not given the question, and remember one more thing, just forget about this chapter number. We are doing it from different books. So the chapter is law of motion, that's it. So a car of mass 480 kg, the mass of the car is given. So I am doing the answer here. These are easy problem, remember. So write it exactly and accumulate the datas like this. Mass they have given, moving at a speed of 54 kilometers per hour. Moving means it is initial velocity. So you should write initial velocity. Initial velocity, that is u, equals 54 kilometers per hour. Kilometers per hour is not the SI unit. So I'll be converting it into SI system. 54 into 5 by 18. You know how to convert it. That is 3. That is 15 meters per second. So this is your initial velocity. Is stopped. Stopped means final velocity is 0. So final velocity is velocity, that is V equals 0. How I have concluded? That is stop. By applying brakes in 10 seconds, so they have given time. Time equals 10 seconds. So this is called the accumulation of data. I have taken the data from the given problem. Now calculate the force. So remember, for force, this is a plan I am doing. Force equals mass, which is already given. See, mass is 480. This is mass into acceleration. So what quantity we don't know here in order to find the force? Acceleration. So I'll put the value of, or find out the value of acceleration here as the car stops. It is retardation. So V minus u by t, V is 0 minus u, it is initially moving with 15 meters per second and time taken to stop the car is 10 seconds, so 10. So that gives me minus 1.5 meter per second to the power minus 1. So I will be taking only the positive value. Why? The negative sign is indicating that it is a retardation. Retardation nothing to do with force. So see here. So I will find the force like this. Mass they have given 480 into, that is 1.5. So 480 into 1.5. So that gives me 720 Newton. So hope you have understood this one. Expect this type of numerical in your exam. So it is a next numerical is like this. A force causes an acceleration of 10 meters per second square. A force causes an acceleration they have given 10 meters per second square in a body of mass 500 grams, not kg. What acceleration will be caused by the same force in the body of mass 5 kg? See, first of all, from the first given condition, we will find out the amount of force. So here, I am doing the answer like this. Here, force, we all know, force equals mass into acceleration. In place of mass, what should I put? 500. So I am converting 500 into kg. So that gives me kg into acceleration is 10 meters per second square. So that gives me 0.5 into 10. So that gives me 5 Newton force. So the force which can be applied, or the force which acts on this body of 500 gram is 5 Newton. Now the second part. What acceleration will be caused in the by the same force? This is a key word. So for the second case, I could write it like this. For the second case, force applied is 5 Newton. And what about the mass of the object? Mass they have given 5 kg. So we will be putting that into same relation. Force equals to mass into acceleration. So 5 equals mass they have given 5 kg into acceleration, and acceleration is equals to 5 by 5, that gives me 1 meter per second square. So the acceleration produced in the second body will be 1 meter per second square. So here remember, from the first case you have to find out the amount of force, and in the second case by applying that value we have to find the acceleration of the body.